This is the part 7 of mathematical physics. Fourier integral. Any periodic function may be represented by a Fourier series. Fourier integral for fx is equals to 1 by pi limits integral limits 0 to infinity and again integral minus infinity to plus infinity ft cos mu t minus x du dt for Fourier sine integral f of x is equals to 2 by pi integral limits 0 to infinity integral 0 to infinity ft sine ut sine ux du dt. Here for odd function f of x equals to 0. Now for cosine Fourier cosine integral f of x is equals to 2 by pi integral limits 0 to infinity integral limits 0 to infinity ft cos ut cos ux du dt. And similarly for odd function fx equals to 0. Now Fourier's complex integral f of x equals to 1 by 2 pi integral limits minus infinity to plus infinity e raised to power minus I ux du integral minus infinity to plus infinity ft e raised to power I ut dt. Now for doing Fourier integral, some important results. Integral limits 0 to infinity sine ax divided by x dx equals to pi by 2 and integral 0 to infinity limits e raised to power minus x square dx equals to root pi by 2 and integral limits from minus infinity to plus infinity sine mx divided by x minus b whole square plus a square dx is equals to pi by a e raised to power minus am sine bm. Let's do questions on this topics. Given f of x is equals to 1 for mod of x is less than 1 and 0 for mod of x is greater than 1. Now f of x is equals to 1 by pi 0 to infinity minus infinity to plus infinity ft cos mu t minus x dt du dt. And also in this question prove integral prove integral 0 to infinity limits sine lambda cos lambda x d lambda divided by lambda is equals to pi by 4. So let's integrate this term for finding fx, Fourier integral, and let u is equals to lambda and du is equal to d lambda. So this integral become this. Now putting the value of ft, ft is given as 1 for the value of for the limits of mod of x is less than 1 and 0 for mod of x less than greater than 1. So limits is taken from -1 to 1 for ft. So we can write here ft is 1 into cos lambda t minus x dt d lambda. Now integrating this term, we get sine lambda t minus x divided by lambda, and here it is d lambda. On integrate, after putting the limits, we get this d lambda. On integrating this term, we get after solving this, we get here divided by lambda is equals to 1 by pi integral 0 to infinity, and using here the formula of sine a plus sine b, sine a plus sine b, which is equals to 2 sine a plus b divided by 2 into cos a minus b divided by 2. Here using divide by 2 into cos divide by 2, and this whole term is divided by lambda and multiply by dx. After solving this term, we get here this term divided by lambda, and this is equals to fx. Now or we can write this like that, is equals to pi by 2 f of x. Here in this question we need to prove this. So given that f of x is given 1 and 0 for mod of x is less than 1 and greater than 1. So we can write here pi by 2 into 1 for mod of x is less than 1 and pi by 2 into 0 for mod of x is greater than 1. Here for mod of x equals to 1, which is a point of discontinuity. So we can write here this integral equals to pi by 2 plus 0. Here this is 0 will become and divide by 2 and equals to pi by 4. Here hence integral 0 to infinity sine lambda cos lambda x divided by lambda d lambda is equals to pi by 4. Hence proved. Or if we put here this value, we get f of x is equals to two by pi integral 0 to infinity sine lambda cos lambda x d lambda divided by lambda, and this become this 1 by 2. Let's do a question on Fourier sine integral. F of x is given as e raised to power minus kx. Here k is greater than 0. Now Fourier sine integral is equals to 2 by pi integral minus 0 to infinity sine mu ux du integral 0 to infinity ft sine ut dt, and replace here u by lambda and du by d lambda. F of x is equals to in this question we need to prove that pi by 2 e raised to power kx is equals to integral 0 to infinity k cos lambda x divided by k square plus lambda square into d lambda. Now replacing here u by lambda, so this integral become this sine lambda x d lambda integral 0 to infinity ft sine lambda t dt, and putting the value of f of x, which is given as e raised to power minus kx. Here we used here formula of sine integral e raised to power ax sine bx dx, which is equals to e raised to power ax divided by a square plus b square a sine bx minus b cos bx. Now this f of x is equals to e raised to power kx, we can write here, and equals to 2 by pi integral 0 to infinity sine lambda x d lambda. And using this integral formula, here you can see here this x is t and this a is minus k. So replace this value. We can write here e raised to power minus kt divided by k square plus, and this is b is lambda, so b square is lambda square into a is minus k sine lambda t minus lambda cos lambda t, and limits are from 0 to infinity. Now putting this value, we get here 0 plus lambda by k square plus lambda square. For value of infinity, as we put in this values on the value of e raised to power minus kt, if we put here infinity, this term becomes 0. So multiply by this term, become all these terms are 0 for this, and after putting the value of t is 0, here this term become 1 and sine lambda t become 0 and this cos term become 1. So we get this value. Now we can write here this, as you can see here, we need to prove pi by 2 e raised to power minus kx equals to integral 0 to infinity limits k cos lambda x divided by k square plus lambda square dx. Here you can see this is that value and this is e raised to power minus kx. So we can write here, or pi by 2 e raised to power minus kx is equals to 0 to infinity sine lambda x dx, sorry, d lambda, this is d lambda, and divide by k square plus lambda square, hence proved. Similarly, for cosine series, if we use here Fourier cosine integral, this also, this value is equals to integral 0 to infinity cos lambda x d lambda divided by k square plus lambda square. Sorry for this mistake, there is a lambda also here, and here in this become k. Now let's do a question on Fourier cosine integral. We need to prove this equals to pi by 2 into e raised to power minus kx divided by k. Here x is greater than 0 and k is greater than 0. Now using Fourier cosine integral, which is equals to f of x is equals to 2 by pi integral 0 to infinity cos mu x integral 0 to infinity f of t cos ut dt. Here similarly we put here u equals to lambda and du d lambda. Sorry, in this question is there is omega w, so we put here u is w and du dw. So f of x becomes this cos wx dw integral 0 to infinity ft cos omega t dt. Here for this question ft is given as e raised to power minus kt. Now here we put e raised to power minus kt. Now after integrating this term using this formula integral e raised to power ax cos bx dx is equals to e raised to power ax divided by a square plus b square into a cos bx plus b sin bx. We get here e raised to power minus kx divided by k square plus w square into minus k cos omega t plus w sin omega t. Here this f of x is equals to e raised to power minus kx. We can write here this. Here the limits of this are 0 to infinity. After putting limits we get here this term. Or we can write this and this becomes pi e raised to power k divided by 2k equals to 0 to infinity limits cos wx dw divided by k square plus omega square. Hence proved. Let's do another question. Integral cos x omega plus omega sin x omega divided by 1 plus omega square d omega equals to 0 pi by 2 pi e raised to power x if x is less than 0, if x equals to 0, if x is greater than 0. This term, this integral we can write like that. Plus integral 0 to infinity omega sin x omega divided by 1 plus omega square d omega. As we done this question, sorry, this here in this question we get here this value for lambda sine lambda x d lambda divided by k square plus lambda square, and similarly for, sorry, here is cos lambda x d lambda, and similarly for this we get this value. So using this integral we can write here pi by 2 e raised to power minus x plus pi by 2 e raised to power minus x. Now using these three cases in this question we need to find which value represent Fourier integral. So for x is less than 0, here you can see here integral cos, if x is less than 0, so value of x is negative, so we can write here this term which is equals to, here as we know integral of this term is become this, and here this is minus x, so we know that sine minus x is equals to minus sine x, so this term become this minus pi by 2 e raised to power minus x and equals to 0. Now according to second condition, if x equals to 0, so put in the integral x equals to 0, we get these terms, and equals to tan inverse omega and limit 0 to infinity. If we put here omega is infinity, tan 90, tan pi by 2 is infinity, and tan 0 is 0, so we get here pi by 2. Now third, when x is less than 0, sorry, greater than 0, if x is greater than 0, then this integral becomes pi by 2 e raised to power minus ex, pi by 2 e raised to power minus x, and equals to pi e raised to power minus x. Hence these all three conditions satisfy, hence these values represent a Fourier integral. Now Fourier transform f of x is equals to 1 by root 2 pi integral minus infinity to plus infinity e raised to power minus iota s x fs ds. This is inverse Fourier transform. And here this fs is Fourier transform. And f of s is equals to 1 by root 2 pi integral limits minus infinity to plus infinity ft e raised to power iota st dt. Now Fourier sine transformation f of x is equals to root 2 by root pi integral 0 to infinity limits f of s sine sx ds. Here this is inverse Fourier transform, sorry, inverse Fourier sine transform. And here f of s is Fourier sine transform, which is written as in root 2 by pi integral limits 0 to infinity f of t sine st dt. Similarly, for Fourier cosine transformation, the only change is sin x and this is inverse Fourier cosine transformation, and this fs is Fourier cosine transformation. Let's do question on Fourier transformation. F of s is equals, sorry, given fx is equals to 1 for mod of x is less than 2a and 0 for mod of x is greater than a. Find the Fourier transform of this f of x. So Fourier transform of f of x is equals to this, and using here 1 by root 2 pi integral minus infinity to plus infinity f of x, sorry, f of s e raised to power iota s x dx equals to 1 by root 2 pi integral, here you can see limits are from minus a to plus a, so we can put here, and f of s is given as 1 for when mod of x is less than to a, so we can write here 1 e raised to power iota s x dx. On their integration we get let's put the limits. Multiply by and divide by 2 both sides in numerator and denominator, and here you can see this term is sin x, so we can here x is represented by sa, so we can write here sa, so this become 2 sin sa divided by root 2 pi s, or we can write here root 2 by pi sine sa divided by s. Let's do question on Fourier's sine or cosine transformation. Question. In this question we need to find Fourier sine transformation and cosine sine trans cosine Fourier transformation also. Now Fourier sine transformation is denoted by this s, so we can use here root 2 by pi integral 0 to infinity, where fs is this, sorry, ft is x raised to power n, so we can write here x raised to power n minus 1 into sine sx dx. Similarly, for Fourier cosine transformation of x raised to power n minus 1 equals to root 2 by pi integral 0 to infinity x raised to power n minus 1 cos sx dx. If we can write these two equation like this, so we can write here we can take common x raised to power n minus 1 and write here cos sx plus sine sx dx. Here there is iota term also here, and you can see this is equals to e raised to power iota sx, so we can write here into x raised to power n minus 1 dx. Let iota sx equals to minus t, and here x equals to minus t by iota s, and here iota sx dx equals to minus dt. Here you can see limit doesn't change, value of x equals to 0, t also 0, and for infinity t also infinity. So we can write here this here you can see there is minus 1 divided by iota x in this term, so we can take common, or we can write here t raised to power n minus 1 into minus 1 here dt. These are both same term, sorry, these are same terms, so their power add, so we can, and also these are constant, so we can take outside the integral, so we can write here this, and this become e raised to power minus t into t raised to power n minus t dt. Here this is gamma function, so we can use here gamma function, and this become gamma n, or we can write here minus 1 is equals to cos pi by 2 plus iota sine pi by 2. Why I use this? Because in starting for this we use here this term, so we need imaginary term also. So we can write here this. So this become, and this is into gamma n divided by s raised to power n. Here and also is there is iota n, sorry there is no, because there is one value. As you can see here in this term there is minus 1 raised to power n and divided by iota raised to power n, or we can write this as minus iota raised to power n into 1 divided by iota raised to power n, and this term is cancelled out by, sorry, this equals to this. And as we know that iota is equals to this, so we can write here this, and these are both same terms, so we can write here sorry for this. Here this equals to this, we can write this term as minus iota raised to power 2n. If we square this iota, this become minus 1 and divide by I raised to power n, and these are same terms, so this become iota raised to power n. Sorry, iota is equals to cos pi by 2 plus iota sin pi by 2. So this term become, using here De Moivre's theorem, this n go here and this become this, and this is gamma n and divided by s raised to power n. Comparing both side, we get Fourier cosine transform of x raised to power n minus 1 equals to this term, and Fourier sine transformation of x raised to power n minus 1 equals to this, x raised to power n sine n pi by 2. Here in this question there is another second part also, which is 1 by root x. As you can see here, this is x raised to power n minus 1. If we put here n equals to 2, this become 1 by root x. So put n equals to 1 by 2. So we get here Fourier cosine transform of x raised to power minus 1 by 2 equals to root 2 by pi gamma n divided by s raised to power Sn cos pi by 4. So this is 1 by 2, because here we put n equals to 1 by 2, and gamma 1 by 2 is equals to root pi. So this will cut by this term, and cos pi by 4 is root 2, and this term is cut by this root 2, and this become, and sorry, this is also 1 by 2. So the answer is become s raised to power of minus 1 by 2. And similarly for Fourier sine transformation of x raised to power minus 1 by 2 equals to root 2 by pi into gamma n by Sn into sine pi by 4, and this also equals to s raised to power minus 1 by 2. This is 1 by 2 and this is also 1 by 2. Now properties of Fourier transformation. Fourier transforms. First is linear property. Fourier transform of a f1x plus b f2x equals to a f1s plus b f2s. Now second property is change of scale property. Which is Fourier transform of f of ax equals to 1 by a f s by a. Here if f of ax is given as like that 1 by s a e raised to power minus as, so using this property we can find f2ax values. Here you can see putting here 1 by a, which is 2, and here you can see when this is s divided by a, so we can write here 1 by s by 2 into e raised to power minus as by 2, and this become e raised to power minus as by 2 divided by s. This 2 is cancelled out by this 2. Now third property is shifting property. Now Fourier transform of f of x minus a equals to e raised to power iota s a f s. If here there is a plus sign, so we can write here minus isa f of s. If there is iota term, means iota a, so this term become e raised to power minus s a f s. And similarly for plus iota a, here this term becomes e raised to power minus s a f s. Now fourth property, Fourier transform of e raised to power iota ax f x equals to f s plus a. Similarly for, as we used in shifting property, different value of a, also we can use here also. If this iota term is not here, so this become s plus iota a, and similarly if there is a minus sign, so this plus sign become minus sign. Now fifth property, modulation theorem. Fourier transform of f of x cos ax equals to 1 by 2 Fourier transform f of s plus a plus f of s minus a. Now sixth property, if Fourier transform of f of x equals to fs, then Fourier transform of x raised to power n f of x equals to minus iota raised to power n differentiation n times with respect to s fs. Now seventh property, Fourier transform of f dash x is equals to iota s f of s. Now eighth property is Fourier transform of integral a to x f of x dx equals to f of s divided by minus iota s, or we can write iota by s f s. Now convolution theorem. F of x into gx equals to minus infinity to plus infinity fu gx minus u du. Here, if we take Fourier transform of fx gx equals to Fourier transform of f of x into Fourier transform of f gx. For their inverse transformation, we can write here this equals to this. Fourier inverse transform of f of s into Fourier inverse transform of gs. Now another identity is Parseval's identity for Fourier transformation. First is integral minus infinity to plus infinity limit f of x gs bar. This is a complex conjugate of gs. ds integral minus infinity to plus infinity f of x g bar x dx. Here similarly this is a complex conjugate of gx. Now second property is this mod of fx square ds is equals to integral minus infinity to plus infinity mod of fx square dx. And another properties are this 2 by pi integral 0 to infinity f of x g s dx is equals to integral 0 to infinity f of x gx dx. Now another important identity is 2 by pi integral 0 to infinity mod of fs square ds is equals to integral 0 to infinity mod of f of x square dx. Here this is for Fourier cosine transformation and this is for Fourier sine transformation. Now let's do question on Parseval's identity. We need to prove that this integral equals to pi by 4. Here, using second Parseval identity, so we need to find f of x, which is equals to, here you can see here, x by x square plus 1. Here Parseval identity is minus infinity to plus infinity f of s whole square ds is equals to minus infinity to plus infinity mod of f of x whole square dx. Here we also need to find f of s. So Fourier transform of f of x is equals to fs. So after finding their Fourier transformation of x by x square plus 1, we get this value. Now putting this value for verifying Parseval identity, this integral. Here f of s is pi by 2 e raised to power minus s whole square ds. Sorry, here this is also here 2 by pi also. Here in this we use here sine Fourier sine integral. This is mod square x d here. Or we can write here integral 0 to infinity x divided by dx is equals to, here x is real number, so we can write here this, and after solving this integral we get here there is also 2 by pi ds, and this equals to pi by 4. Let's do another question on Parseval identity. Let's do some question on Fourier Fourier transformation property of this. Let's do d to phi by dx square minus k square phi equals to f of x. We need to show that phi x is equals to minus 1 by root 2 pi integral minus infinity to plus infinity e raised to power iota omega x f omega dw divided by omega square plus k square. As we know that here using here phi instead of using f dash x, so we use here phi dash x is equals to iota, and here you can see there is no s term in, so we use here w omega f phi x. So if we again use here f phi double dash x equals to this. And if we do Fourier transformation of this, so this become this. Now taking Fourier transformation in this equation both side, we get here minus omega square phi omega minus k square phi omega equals to f omega. Here phi omega is a Fourier transformation of phi x. So we can write here, taking common phi omega equals to minus f omega divided by omega square plus k square, and taking here inverse transformation, so phi x is equals to minus, here is a minus term also, so we can use this minus term, and this become this e raised to power iota omega x. Here s is, here is omega, so this become this. Here f of x is equals to integral e raised 1 by root 2 pi integral e raised to power iota s x fs ds. Here using this formula we can write here this. Now let's do a question on Parseval's identity. We need to prove that sine t by t square dt is equals to pi by 2 for f of x is equals to 1 for mod of x is less than 2a and 0 for mod of x is greater than 2a. So f of s is equals to root 2 by pi sine as divided by s. Using a Parseval identity, minus infinity to plus infinity, f of x we write here instead of x t, because here you can see the function for is t, so we use here t, and dt is equals to minus infinity to plus infinity f of s mod square ds. Here ft is given as 1 for mod of x greater less than 2a, so limits become minus a to a 1 square dt is equals to minus infinity to plus infinity. Here f of s is given as you see here sine as divided by s root 2 by pi. Here we can write, so after putting this value we get this. On solving, both side we get this. Now another topic is Laplace transform. Why we need Laplace transform? As we know that Fourier transform is one of the most powerful method of operational calculus. Often we encounter function for which its Fourier transform does not exist. That's why we need Laplace transform. Here Laplace transform is written as like this: integral limits 0 to infinity e raised to power minus st ft ds dt. Here ft is piecewise continuous in every finite interval, and ft second at most be of order e raised to power at, where a is a constant. The inversion of Laplace transform is not easy operation. The general method of obtaining inverse Laplace transformation uses complex analysis and will not be pursued here. Now, property of Laplace transform is Laplace transform of AFT plus BGT is equals to AFS plus BGS is equals to A Laplace transform of FT plus B Laplace transform of GT. Now, another important properties of Laplace transform. Laplace transform of 1 is 1 by S, and Laplace transform of t raised to power n is equals to factorial n divided by s raised to power n plus 1, and Laplace transform of e raised to power at is equals to 1 by s minus a. Here s is greater than a. Now Laplace transform of cos at equals to s by s square plus a square. Laplace transform of sin at equals to a divided by s square plus a square, and Laplace transform of cos hyperbolic at equals to s by s square minus a square, and Laplace transform of sine hyperbolic at is equals to a by s square minus a square. Here properties of Laplace transform. Laplace transform of f at is equals to a by f s by a. Second property is first shifting theorem. If Laplace transform of ft is equals to fs, then Laplace transform of e raised to power at ft equals to fs minus a. Using this formula, we need to write first of all Fourier transform of Laplace transform of e raised to power at, then find the Laplace transform of this ft. Now third property is Heaviside shifting theorem. If Laplace transform of ft is equals to fs and gt is given as ft minus a, when t is greater than a, and 0 when 0 is less than t and t is less than 2a. Then Laplace transform of gt equals to e raised to power minus as fs. And fourth property is Laplace transform of f dash t is equals to as Laplace transform of ft minus f0 for nth n order derivative. Laplace transform of f raised to power f having a derivative n times equals to s raised to power n Laplace transform of ft minus s raised to power n minus 1 f0 minus s raised to power n minus 2 f dash 0 minus s raised to power n minus 3 f double dash 0 up to f raised to power n minus 1 0. Now fifth property, Laplace transform of integral 0 to 2 t f t dt is equals to 1 by s f of s. Sixth, Laplace transform of t raised to power n f t equals to minus 1 raised to power n d raised to power derivative n times with respect to s f of s. Now seventh property is this, and this is equals to integral s to infinity limits f of s ds. Eighth property is for periodic function is given. Then Laplace transform of ft is equals to integral 0 to capital T e raised to power st f ft dt divided by 1 minus e raised to power minus st. Ninth property is ft is equals to integral limit from t to infinity e raised to power minus x divided by x dx. And if this given, then Laplace transform of this integral, let's say this is I equals to log s plus 1 divided by s. Now 10th property is second shifting theorem. Laplace transform of ft minus a into ut minus a equals to e raised to power minus as fs. 11th property, Laplace transform of ft ut minus a equals to e raised to power minus as f Laplace transform of ft plus a. Now convolution theorem. Laplace transform of integral 0 to t f1x f2 t minus x dx is equals to f1s f2s. Now their inversion means inverse transformation become this. For Laplace inverse transformation, you write these values all are the reciprocal of Laplace inverse transform. If we find Laplace inverse transform of 1 by s equals to 1, and similarly for this Laplace transform of s raised to power n is equals to inverse transform is equals to t raised to power n plus 1 divide by, sorry, there is n minus 1 and divide by n plus 1 factorial. And similarly for this, Laplace transform of 1 by s minus, Laplace inverse transform of 1 by s minus a is equals to e raised to power at. Let's do a question. Here, as we know that cos 2 theta is equals to 2 cos square theta minus 1, put here, and we can use here 2 plus 2 cos 4 theta. Here Laplace transformation of 1 is s, 1 by s, so we can write here 2 by s plus, and Laplace transformation of 2 cos 4 theta is become this. Here you can see a is 4, so a square is 16. And let's do another question. Laplace transformation of e raised to power minus 2t cos 4t. Here using Laplace transformation of e raised to power minus at ft equals to f of s plus a. This property here we use. So need to find Laplace transformation of cos 4t and equals to s by s square plus 16. Now let's find the Laplace transformation of e raised to power minus 2t cos 4t is equals to, here where is the s present, we need to put here s plus a term. So put here s plus 2 divide by s plus 2 whole square plus 16. Here you can see the value of a is 2. Let's do a question on convolution theorem. Given this value is given as, and we need to find their Laplace transformation using convolution theorem. Here Laplace transformation of 0 to t e raised to power x sine t minus x dx is equals to f1s. So Laplace transform of ex we need to find, and also sine t, Laplace transformation of sine t minus x. So it's become Laplace transformation of ex is equals to s minus 1. Here a is equals to 1, and Laplace transform of sine t is 1. Here there is no term multiply to this term, so we use here Laplace transformation of sine ax is equals to a by s square plus a square. Here you can see here a is 1, and here this x is t minus x. Let's do a question on inverse Laplace transformation. Let's do this question by convolution theorem. F of s is equals to this, and gs is equals to 1 by s square plus w square. For this type of question doing, we need to let f, s and gs value in the question. If we multiply f and fs and gs, this become 1 by s square plus omega w square whole square. So we need to find Laplace inverse transformation of fs gs, which is equals to this fu g t minus u du, and equals to this. Here we need to put here on the value of fs is u in or u instead of s, so we get here 1 by s square plus u square, and in gs we put s equals to t minus u. Sorry, we need to find their Laplace inverse transformation. So Laplace inverse transformation of f of s is equals to 1 by a sine wt, and Laplace inverse transformation of gs is equals to 1 by a sine omega t, and we need to put this value in this formula. Here in this value we put here u instead of t, so this term become, and oh sorry, this is not a, this is w, so we can write here this into 1 by w sine wt minus u du. Here using here sine x plus sine y, sorry, sine x sine y identity, multiplying and divide by 2 both side, and taking w common, so in taking common inside, and integral become this du. As you see, cos wt is constant, so integration of this term become this, divide by 2 w minus u cos omega t, limits from 0 to t. After putting limit we get this value, thank you.